You need to work through these before looking at the answers. You can press pause. You can mark your work and then decide if you need to go through the details of the answers. So, you're going to write the chemical names. Remember, using stock notation when you don't need stock notation is incorrect. Not using stock notation when you do need it is also incorrect. So you need to be aware of when you're going to need stock notation. You will need it when you've got a transition element that is not zinc or silver. So we're going to need stock notation for that one. Barium is over here. It's in group 2, so no stock notation. Sodium, no stock notation. Copper is here in the transition, so it will need stock notation. Copper's in the transitions. Iron's in the transitions. Iron's in the transitions. Potassium is over here in group 1. We won't need stock notation there. Ammonium is a polyatomic ion. We will not need stock notation for polyatomic ions, nor for potassium, which is in group 1, nor for calcium, which is in group 2, nor we will need it for chromium because chromium is in the transitions. We're going to need it for mercury because mercury is in the transitions. We're going to need it for copper because it's in the transitions. Mercury is in the transitions and sodium is not. So let's do the easy ones first. Get them over and done with because you just need to know the names. So it's going to be barium and ClO3 is chlorate. No stock notation required. Sodium, sulfite. Spelled either with a PH or with an F, officially with an F, I think. Potassium, bicarbonate. HCO3 is the bicarbonate ion. Ammonium, phosphate. Potassium, chlorate. Calcium, PO4 is the phosphate ion. And sodium carbonate. CO3 is the carbonate ion. If you put stock notation for any of those, it is incorrect. Alright, so now we're going to take a look at the ones you do need stock notation for. And I'm going to first just write their names without the stock notation. So this is mercury, something or other, bicarbonate. Then we have got copper. NO3 is the nitrate ion. NO2 is the nitrite ion, so it's going to be copper, nitrite. Iron, sulfate. And here again it's iron sulfate, but we probably have a different stock notation. Then we've got chromium hydroxide. Mercury sulfate. Copper phosphate. And mercury nitrate. So naming is quite easy until we get to this bit where we need to work out how many arms the various things have got. So the first one, I have got 1 copper and 2 nitrates, CuNO3, and NO3s come with 1 arm, which means that that copper must have 2 arms. The next one, I've got 1 copper and 1 nitrite, NO2 has 1 arm, and therefore that copper over there would have 1 arm. Iron sulfate, Fe, 1 iron, SO4, 1 sulfate. Sulfates come with 2 arms, therefore this iron over here must have 2 arms. iron sulfate again, except that this time I've got 2 ions and 3 SO4s. So those SO4s each come with 2 arms. So I've got 6 arms altogether and 2 ions to distribute those 6 arms over, so they each need 3 arms. Then we've got chromium hydroxide. There is 1 chromium and there are 2 hydroxides. The hydroxides each come with 1 arm, therefore this chromium is going to require 2 arms. Mercury sulfate, we've got Hg, and the sulfate ion SO4 as a group has 2 arms, therefore this mercury is going to require 2 arms. Then we have got copper. There are 3 coppers in this story. Tells me 3, and then phosphate, PO4, there's only 1 phosphate and they come with 3 arms. How many arms must each of these coppers have? Only 1. Then we've got mercury nitrate, so it's Hg, 1 Hg, and then there are 2 nitrates, NO3, each come with 1 arm, meaning that this mercury over here would need to have 2 arms in order to hold hands with those nitrates.